Cognizant to the needs of our learners, parents, and teachers, the Department of Education provided us with powerful tools for productivity that will allow us to foster critical thinking skills, problem-solving skills, communication and collaboration skills to be compassionate, responsible global citizens. Join us and discover new ideas in our series of professional development training program with the SHS-Edtech Unit and Microsoft Education Philippines. Together, we will equip our learners and empower our fellow educators for a dynamic future. Para sa bata, para sa bayan, at para sa guro. Sulong Edukalidad. Mabuhay! Good day to all! I am your tutor Madge. Welcome to ETUlay, a free online tutorial, an initiative of the Department of Education, Information and Communications Technology Service, Educational Technology Unit, SHS-Edtech. This program is aimed at helping and assisting learners from kindergarten, senior high school, ALS, Alive, and SPED learners. Aside from answering the modules, the ETUlay is offering programs which you will surely look forward to. Together with our parents and teachers, the ETUlay will bridge the gaps where difficulty and ease meet in learning new knowledge and skills. So, let us prepare our modules, pen and paper. Ready your mind to see and hear worthwhile and interesting lessons. Let us now study and learn, together with our volunteer online tutors. Tara na!
Hello, magandang hapon po. We're live, Tutor Nel.
Ayan, magandang hapon po sa ating lahat, mga live viewers. Good Monday afternoon po sa ating mga manonood from Luzon, Visayas at Mindanao. Kumusta po ang ating weekend? Hopefully ay nag-enjoy po kayo.
Welcome to week 2 of quarter 3. Sabay-sabay tayong matuto at maging mahusay sa physical science. Samahan niyo po kami, si Tutor Lester.
At ako naman po si Tutor Nel.
Huwag po kalimutan i-react at i-share po ang ating live session ngayong hapon.
For the second week of the third quarter of the school year 2021-2022, we will discuss the topic polarity of molecules. Ang pinagbasehan po ng ating live session ay ang Physical Science ADM modules ng Region 4A Calabarzon.
For week number 2, ang most essential learning competency na siyang tatalakayin natin for this week is determine if a molecule is polar or non-polar given its structure.
Ngunit bago ang lahat, i-review po muna natin ang mga concept na napag-usapan natin last week. A star's energy is derived from the fusion of hydrogen and helium in its core. Elements are formed in the core of the stars, and elements can be synthesized in the laboratory.
The concepts to be discussed this live session ay mostly na-discuss na po during our junior high school science. So let us refresh those concepts. Okay. Chemical bonds are formed when atoms lose, accept, or share electrons. One of these bonds is the ionic bond. In the ionic bond, a metal loses an electron and the non-metal ion accepts the electron. In the illustration given, we can see here, a sodium ion or cation loses a valence electron, which is accepted by the fluorine ion.
Covalent bonds, on the other hand, are formed by sharing of valence electrons. Shown here in the example is a hydrogen molecule sharing their lone electrons. Hydrogen is an exception to the octet rule, which states that an atom must have 8 electrons in its valence shell to become stable. Hydrogen can be found with just 2 electrons.
Ang talakayan natin ngayong hapon is centered on determining the polarity of the molecules through the electronegativity difference of the atoms involved and the geometrical shape of the molecule that is determined by the valence shell electron pair repulsion theory.
Bawat atom ay may kanya-kanyang electronegativity values. The higher the En value, the stronger the atom's tendency to attract electrons towards itself. The trend in electronegativity is that it increases across a period, or from left of the periodic table to the right. Electronegativity increases because across a period, atoms have a greater nuclear charge and a smaller covalent radius. This allows the nucleus to attract the bonding electrons more strongly. Iba naman ang trend when it goes down the group. Down the group, the electronegativity decreases. As you move down a group in the periodic table, atoms increase in size with a greater number of energy levels. The extra energy levels and increased covalent radius keep the bonding electrons further away from the nucleus. That explains the decrease in the electronegativity values.
Thanks, Tutorial. So the trend is that the electronegativity value of the elements in the periodic table increases from left to right or across a period. So elements found on the left side are less electronegative compared to the elements na nasa right side in the same period. The electronegativity value, however, decreases down the group, which means that the elements in the upper periods are more electronegative than the elements found at the bottom rows of elements or periods. The electronegativity value are indicated per element in the periodic table. The presentation of the values may differ per periodic table that you may find in the bookstores.
Now, if the polarity of the molecules are determined by electronegativity values, so can we predict the type of band that exists in the atom using electronegativity values? The answer is yes. By using the electronegativity difference of the two atoms, we can predict the type of bond these atoms can possibly have. We just have to subtract the En values of two atoms and base it on the range of values that will be discussed by Tutor Lester.
All right. So the following are the ranges of electronegativity difference values. Electronegativity difference higher than 1.7 are considered ionic bond. If the electronegativity difference is within the value range of 0.5 to 1.6, the bond is considered polar covalent. And lastly, electronegativity difference less than 0.5 or having the value range of 0 to 0.4 is considered non-polar covalent. Alright, ulitin ko po. Electronegativity difference higher than 1.7 are considered ionic bond. Electronegativity difference within the value range of 0.5 to 1.6, the bond is considered polar covalent. And electronegativity difference less than 0.5 is considered a non-polar covalent.
Let us provide you some examples using the three compounds enumerated. We are going to predict the type of bond the following compounds: calcium chloride, chlorine molecule, and hydrogen chloride. We just have to identify the difference of their electronegativity values.
All right. For calcium chloride, we subtract the electronegativity value of chlorine, which is equal to 3.0, from the value of calcium, which is equal to 1. So just disregard the negative value. So from the difference, we can predict that the type of bond formed is an ionic bond. Ionic bonds involve a metal cation and a non-metal anion. From the composition of the molecule, it is of great certainty that the bond is indeed an ionic one.
For a chlorine molecule, the electronegativity difference is equal to 0, which says that it is a non-polar covalent bond. Chlorine do not exist as a standalone element. It exists as a compound. The bond is created by two chlorine atoms by sharing their electrons.
And lastly, the electronegativity difference between hydrogen at saka chlorine is equal to 0.9, na nagsasabi that the bond formed between them is a polar covalent bond. A polar covalent molecule has a partially positive atom, in which in this case is hydrogen, and a partially negative atom, which is chlorine. In this case, the prediction by electronegativity difference is accurate.
At ngayon naman, Tutor Lester, bibigyan natin ang ating mga live viewers ng pagkakataon to predict the bond present in the pairs of atoms as seen in the slides. You may need to have your periodic table with you for reference ng mga electronegativity values.
That would be great, Tutor Nel. So we will be acknowledging po ating mga live viewers who will be participating in the activities during this live stream. You may not need to do it now, so pwede nyo pong gawin pa po later. And you will submit your output later po. Pwede po, paki-screenshot na lamang po ang nasa screen for you to work on it later on, or pwede nyo pong i-chat down sa inyong mga notebooks. Isesend nyo lamang po ang inyong mga outputs sa link na ibibigay namin later in this session.
Patiin po muna pala natin ang ating mga live viewers, no? So, medyo marami-rami na po tayo mga live viewers na nandito. Andito po si Jessa May Aserit. Hello po sa iyo. Magandang hapon po. Si Colleen Romiel Manawis. Ayan. Good afternoon. Marichu Modesto. Ayan. So, welcome po sa ating mga sa ating live stream ngayong araw na ito.
Ayan. Let me also take the opportunity to greet some of our live viewers this afternoon. Right, maghanap na po muna ako ng, okay. So magandang hapon po to Crisaline Joy Barut. Okay, from San Mariano National High School, Maine. Welcome to our live session po. Right. So, ayan. Ngayon, ipagpapatuloy ko po ang ating discussion on covalent bond. A covalent bond can be a polar one, meaning the bond in the bond an atom can be partially positive and partially negative. A nonpolar covalent bond, on the other hand, is a type of bond where electron density distribution is equal. We were able to predict the type of bonding as well as the polarity of the compound gamit po ang electronegativity difference. So ngayon, could we be able to predict the polarity of covalent bond by referring to its molecular geometry? Alright. So from our live viewers, inaanyayahan po namin kayong makilahok sa pamamagitan sa pagsagot ng katanungan na nababasa niyo po sa inyong mga screen. So you may comment down your answers in the comment section. So right, ulitin ko po ang tanong, can the molecular geometry help us predict the polarity of a molecule? All right. And the answer is yes. It can help us predict the polarity of a covalent bond by referring to its molecular geometry.
Yeah. Aside from the value range that defines a polar covalent bond, we can describe a polar covalent bond by its unequal sharing of electrons, where one atom is partially positive while the other one is partially negative, which forms an electric dipole. The dipole is represented by this figure. The partially negative atom is the one with a higher electronegativity value, while the partially positive atom is the one with the lower electronegativity value. To accurately portray the partially positive and the partially negative atom with the use of the symbol, do not forget to point the arrow from the least electronegative, which is the partially positive, to the more electronegative atom, which is the partially negative.
All right. So for a non-polar covalent bond, both atoms equally share a pair of electrons between them. Para mas ma-refresh po ang ating memorya on the sharing of electrons, gamitin po natin itong chlorine molecule as an example. Ang chlorine po ay merong valence electron of 7. Chlorine atoms do not exist as a solitary atom. So in nature, they exist as a compound or they exist in pairs. As you can see in the slide po, both chlorine atoms share a pair of electrons between them in order to satisfy the octet rule. So in the octet rule, the atom's valence shell should be filled with 8 electrons. Bilangin po natin ang number of electrons in this molecule. And we also take into account the valence electron of 7 by each chlorine atom. So 1, 2, 3, 4, 5, 6, 7. And then for another chlorine atom, 1, 2, 3, 4, 5, 6, 7. And the total for the two chlorine atoms or the chlorine molecule is 14. So, ang chlorine, gaya po na sinabi ko po kanina, ay merong valence electron of 7. So, when a chlorine atom bonds with another chlorine atom, so this chlorine atom share a pair of electron which is found in the bond. So, ito po yung bond. And a bond consists of 2 electrons. So this shared electron satisfies the octet rule. And if we count the total electrons, the number equal to the total valence electron of two chlorine atoms. So, binilang na po natin kanina, the total of the total valence electron of a chlorine molecule should be equal to 7. And we have here, 14 rather. So we have here 14. For a chlorine molecule, which again exists by pair in nature, both atoms have equal electronegativity value. And kapag kinuha po natin ang electronegativity difference, we will get 0. So chlorine atoms have equal ability to attract electron to each side. Thus, ang bond that exists between them is a non-polar covalent one.
Another way of predicting the polarity of the molecule is by determining the geometry of the molecule through the valence shell electron pair repulsion theory. This is a model used to predict the shape of the molecules. We have different molecular shapes depending on the orientation of the central atom and the terminal atoms. These are the possible shapes: linear, trigonal planar, bent, tetrahedral, trigonal pyramid, trigonal bipyramidal, and octahedral. In the next slide, you will see a table detailing the bonds and the number of lone pairs corresponding to a particular geometry. So, in this table, we have the number of pairs or bonds, the arrangement, the number of lone pairs, and the corresponding geometry. And to be able to determine the molecular shape through VSEPR, kailangan po nating i-review kung paano gumawa ng Lewis dot structures ng mga molecules. We will provide you the link to the site para ma-refresh po ninyo ang pagguhit ng Lewis dot structures. We will also give you our live viewers the link para sa mga kompletong table ng molecular geometries.
Alright? Paki-post lamang po at screenshot po ang link na nababasa nyo po sa inyong screen para mas madali nyo pong ma-access ang site kung paano i-draw ang Lewis dot structure. Alright, babasahin ko po ang link. https /bit.ly/3 9h capital P 0 small w. Okay, ulitin ko po. bit.ly/3 9 small h capital P 0 w. So open po, you just open po a web browser and pwede nyo pong i-type ang link na nabasa nyo po dito sa slide. Once you enter the link, you will be directed to the site giving you instructions on how to draw the Lewis structure. For the molecular geometries, just enter the link po indicated in the screen. The link is bit.ly/capital VS 3PR. Ulitin ko po, bit.ly/capital VS 3PR. Paki-post at screenshot na lamang po ang link para mas madali nyo pong ma-retrieve ang link and access the site which will direct you to the different molecular geometries. So open lang po ng web browser and do what I instructed you to do.
To predict the molecular shape, ay simulan nating tukuyin kung anong atom ang magiging central atom at ang mga magiging terminal atoms. Ating tignan ang mga electronegativity values sa periodic table. Ang atom na may pinakamaliit na value ay siyang magiging central atom. Matapos ma-identify ang central at terminal atoms, i-draw ang Lewis dot structure. We make sure that the number of electrons from the atoms involved are distributed in the structure satisfying the octet rule. Matapos nating ma-draw ang Lewis structure at ma-distribute ang mga electrons, ay ating bilangin ang bonding pairs at non-bonding pairs sa central atom. Kapag nagawa na natin ang unang tatlong hakbang, ay maaari nating maktukoy kung ano ang geometry ng molecule. For our example, ating tukuyin ang molecular geometry ng boron trichloride. We will have Tutor Lester to guide you through the process.
Salamat po, Tutor Nel. Simulan po natin sa pagtukoy ng central atom. So, from the periodic table, we can determine that the electronegativity value of boron is equal to 2.0 at ang chlorine naman ay 3.0. Dahil boron ang may mas maliit na electronegativity value, ito po ang magiging central atom at ang chlorine naman ang magiging terminal atom. To draw the Lewis dot structure, we get the total valence electrons of the atoms first. So ang boron ay may tatlo because it is found in group 3. Chlorine has 7 because it is found in group 7. I-multiply po natin ang tatlong chlorine atoms by 7, which is their valence electron, and add the 3 from boron, and our total electrons is equal to 24. So we will distribute the 24 electrons equally among the atoms. So we will write boron as the central atom. Then we connect the 3 chlorine atoms to the boron central atom via 3 single bond. O yan. So each single bond is equal to 2 electrons. So sa single bonds, sa tatlong single bonds, ay na-distribute na po natin ang 6 na electron. Which means that we need to distribute 18 remaining more electrons. So we distribute the rest of the electrons to the terminal atoms with the octet rule in mind. So dapat po, dapat bawat terminal atom ay may 8 electron. Kung may sobrang electron ay idadagdag lamang po natin sa central atom. Alright. So, yan. Ayan. So, we had distributed the remaining 18 electrons. Alright. So, in this case, wala pong excess electrons. So, now, that completes the 24 electrons of boron trichloride. Dahil na kompleto na natin ang Lewis dot structure, ay bilangin na po natin ang bonding at ang non-bonding pair. So, okay, ito po yung bonding pairs at bilangin po natin ang non-bonding pairs. Right. So, looking at the Lewis structure, meron po tayong tatlong bonding pair. And the number of lone pairs ay wala po. And the non-bonding pairs ay ito po yung makikita natin around the terminal atoms. And now, how do we identify the geometry? So to identify the geometry, we refer to the molecular geometry table. So, ang boron trichloride po ay may tatlong sigma bonds or three single bonds at saka walang lone pair. So, from the table, we can identify that the geometry of boron trichloride is trigonal planar. And both the electron pair orientation and molecular geometry are the same. Pareho pong trigonal planar.
Yan. Now that we are able to determine the geometry via VSEPR, how do we determine if the molecule is polar or non-polar? We can determine the polarity by using these guidelines. Is the shape symmetrical in 3D? If the answer is no, then the molecule is polar. If the answer is yes, ask this question. Are all atoms bonded to the central atoms the same? If the answer is no, then the molecule is polar. If the answer is yes, then the molecule is considered non-polar. Boron trichloride was able to satisfy the conditions set in the last two questions, which are as follows. Is the shape symmetrical in 3D? And are all atoms bonded to the central atoms the same? Dahil pareho pong yes, we can therefore conclude with great certainty that boron trichloride is nonpolar covalent molecule.
Alright. Ngayon po ay pwede nyo pong gawin ang kayong aming mga live viewers ang mga steps na ginawa po namin ni Tutor Nel in determining the polarity of covalent molecules. For your activity, you may predict the molecular geometry of chloroform or CHCl3 and determine its polarity. So, pwede nyo pong gawin itong activity in your most comfortable time after the session. Bibigyan po kayo ng link for you to submit your work at amin pong kikalalanin in the next session ang ating mga live viewers na lumahok po sa ating activities. Alright, so batiin po muna natin ang ating mga live viewers. Right, shout out po sa aking mga mag-aaral sa grade 12 sa ETUlay National High School who are watching, who are here, watching our live session. At shout out na rin po sa non-teaching and teaching staff of all the schools here in SDO or MOC City. At sa ating lahat ng mga viewers from Luzon, Visayas at Mindanao na sinasabayan po tayong manood para matuto at maging mahusay. Hashtag mahusay sa physical science. Okay. So, you may submit po your output in any of the digital formats sa link na nakikita nyo po sa inyong screen. Okay, basahin ko po ang link. bit.ly/351 small f I to capital J. Ulitin ko po, bit.ly/351 small f I to capital J. So, paki-enter lamang po ang inyong pangalan, grade and section, pangalan ng school, at Schools Division Office, at saka i-upload nyo po ang inyong output to be recognized. Ang pag-upload po ng output ay nandyan po sa link na nababasa nyo po ngayon. So you can upload your output in any of the possible format like Word, PDF, or JPEG. Hintayin po namin ang inyong mga submissions, aming mga minamahal na live viewers. Alright. Ngayon po, let's move on to our quiz segment na pinangalanan po nating Gets Mo, Sagot Mo. So dito po sa segment na ito ay may sasagutan po tayong 5 katanungan na of course taken from what we had shared to you earlier. So we are inviting po our live viewers to have fun at sumali po kayo sa ating Gets Mo, Sagot Mo segment. So paki-comment lamang po ang inyong mga sagot. Alright, so let's get started na po.
Yan. Number 1. This refers to the ability of an atom in a molecule to attract shared electrons. A. Electron affinity. B. Electronegativity. C. Ionization energy. And letter D. Electromotive force. The answer is letter B. Electronegativity. Number 2. What type of chemical bond holds the atoms of water molecules together? A. Ionic bond. B. Hydrogen bond. C. Polar covalent bond. Letter D. Non-polar covalent bond. Okay, the answer is letter B. Letter C, polar covalent bond. Now, explanation for the answer. For some of you may think that the answer is hydrogen bond. But reading at the question again, it says that atoms of a water molecules and not water molecules. So definitely, the answer is a polar covalent bond because of the unequal sharing of electrons and the apparent unsymmetrical shape of a water molecule in 3D. Now, let's move on. Number 3. Which of the following molecules is nonpolar? Letter A, sodium chloride. Letter B, hydrogen chloride. Letter C, carbon dioxide. Letter D, ammonia. The answer is letter C, carbon dioxide. Among all the choices, carbon dioxide is the clear answer. If we look at the Lewis structure of carbon dioxide, the central atom, which is the carbon, shows no lone pairs and all the electrons are distributed evenly at the terminal atoms.
All right. For question number 4, what is the electronegativity difference of carbon and oxygen bond? A, 0, B, 0.5, C, 0.89, and D, 1.5. Ang tamang sagot po ay letter C. So bakit po C? So ang electronegativity value of oxygen is 3.44. The electronegativity of carbon is 2.0. We subtract the two values and we get the correct answer, which is 0.89. And last question. From the given Lewis structure of ammonia, how many non-bonding pair or pairs of electron are around the central atom? Letter A, 0. Letter B, 1. Letter C, 2. And letter D, 3. And the correct answer is letter B, 1. So it is very clear that the ammonia's Lewis structure shows a lone pair at the central atom. So ito po yung lone pair.
Before we end this session, ito pong ating paksa na tinalakay ngayong hapon ay nakabase sa contents ng Physical Science ADM Module 3 ng Region 4A Calabarzon. Salamat po sa inyong pagsama sa amin sa nakaraang 40 minutes na umaatikabong live sessions tungkol sa polarity ng molecules. We are inviting everyone to send us their feedback because it matters to us very much. If you are using a device with a QR code scanner, you may scan the code na makikita nyo po sa inyong mga screen. Or you may screenshot the screen for you to scan it later. You may also type in your web browser the link displayed in the bottom area of the screen. That is tinyurl.com/ETUlay feedback form. Again, that is tinyurl.com/ETUlay feedback form.
You may also send your words of appreciation po using the link given. You can also give recommendation if you want someone to be our guest in the live stream next session. We would welcome it po. You may also email your comments and suggestions through the email that you can read in your screen. edtech@deped.gov.ph.
Inaanyayahan din po namin kayo, aming mga minamahal na mga live viewers, nasabayan rin po ang ating mga tutors sa General Biology 2 na sina Tutor Easter ng SDO Caloocan City at Tutor Tina ng SDO Pasig City after this session from 4:40 p.m. to 5:20 p.m.
You may also watch the live session in Empowerment Technologies kasama ang ating mga tutor na sina Tutor Jane of SDO Puerto Princesa City at Tutor Janelle ng SDO Ilocos Sur. Right after this session po from 4:40 to 5:20. And that's it for week number 2. Enjoy the rest of the week kasama ang ibang mga tutor natin sa iba't ibang asignatura. So, kita-kita po tayo muli sa Lunes sa parehong oras from 4 to 4:40 in the afternoon. This is your tutor, Tutor Lester from SDO Ormoc City.
And yours truly, Tutor Ronel from SDO Pasig City.
Goodbye.
Bye.
And God bless.
God bless.
Kita-kita po.
Thank you po.
Ang husay naman! Natapos mo ang iyong tutorial session kasama ang iyong mahusay na ETUlay tutor. May bago ka bang natutuhan? I-share na yan gamit ang hashtag #ETUlayLevelUp. Huwag aalis ha dahil may susunod pang programa na pwede mo ring panoorin at salihan dahil naghihintay na ang iyong mga tutors. Happy learning dito sa ETUlay!